In this video, we're going to discuss the Rational Zeros Theorem. So the Rational Zeros Theorem says that if f of x is a polynomial with integer coefficients, so that's important. We don't have any coefficients that are fractions or square root of 5 or 2i. We don't have anything like that, just integer coefficients. And p over q is a simplified rational number, so it's a fraction. It's been fully simplified, so it's not something like 2/4. It will be written as 1/2. So if this number p over q is a zero of the polynomial, then p has to be a factor of the constant term of the polynomial, and q has to be a factor of the leading coefficient. So here's a simple example of this. Suppose f of x equals x squared minus x minus 6. So the purpose for us using the Rational Zeros Theorem is we're going to be trying to find all the zeros of polynomials. Now obviously this is one, this is a quadratic, we've found the zeros of those before, but higher degree polynomials that are harder to factor is what we're going for eventually. So if we look here, the constant term is -6. So if we think about the numbers that go into -6, well, certainly 1 goes into 6, and so does -1. So rather than listing those separately, I'm just going to list them like this. 2 and -2 both go into 6. 3 and -3, and 6 and -6. Those are our factors of -6. And then our leading coefficient is 1, because we have 1x squared. So the factors of 1 are just 1 and -1. So what this Rational Zeros Theorem says is if a number is a zero of f, then the numerator, if a rational number is a zero of f, then the numerator has to be a factor of -6, and the denominator has to be a factor of 1. So you have numbers like 1 over 1, and that could be positive or negative. For example, if we use the positive 1 from both lists, right, it would be positive 1, or if we use a -1 from one list and a positive 1 from the other list, then it would be -1. So plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1. Those are our potential zeros. So we've got 1, 2, 3, 6, and the negatives of those. So we have 8 numbers listed here as our possible rational zeros for this function. These are all possible according to the Rational Zeros Theorem. Now they're not all zeros because this polynomial has degree 2, so it only has 2 zeros, and we just listed 8 numbers. And some polynomials have zeros that are not rational. But what this does for us is it gives us a list of likely candidates. So for example, now we know not to bother plugging 4 in for x and seeing if it gives us 0 because it's not on the list, so 4 is not a 0. Now to kind of illustrate how this plays out for this function actually factors as x plus 2 times x minus 3. So the actual zeros here are -2 and +3, which are on our list. So like I said, our goal here is going to be to factor and find all the zeros of polynomials for which we don't have a nice factoring technique already that we've learned. And so we're going to need to plug numbers into the function and see if they give us 0. And so this is kind of weeding out, narrowing it down to choices that actually make sense to try so that we're not just trying a bunch of random numbers and getting nowhere. So let's practice using the Rational Zeros Theorem. We're going to list all the possible rational zeros for this function, and this function is going to have the same list as the one we just did, actually. That was poor planning on my part. So the constant term is still negative 6, right? So our factors of negative 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And our leading coefficient is still 1. So plus or minus 1 would be the factors of 1. So these are our possible numerators, and these are our possible denominators. So 1 over 1, 2 over 1, 3 over 1, and 6 over 1, positive or negative. Those are the 8 possible rational zeros. Again, they're not all zeros. This function is degree 3, so not all of these are zeros, and this function might have some zeros that are irrational, like square root of something, or a non-real zero, but we know that any of its zeros that are rational have to be on this list that we just made. All right, let's try this one. We have a constant term of negative 3. So our factors of negative 3 would be 1, negative 1, 3, and negative 3. And then our leading coefficient is 4. So our factors of 4 will be 1, 2, 4, and the negatives of those. So the factors of negative 3 give us our possible numerators, and the factors of 4 give us our possible denominators. So we have 1 over 1, 1 over 2, 1 over 4, 3 over 1, 3 over 2, and 3 over 4. So those are the possible rational zeros for this function. All right, one more. Here we have a constant term of 8. So we'll list our factors of 8. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And our factors of 3 would be plus or minus 1 and plus or minus 3. So our possible rational zeros should have a numerator that's a factor of 8 and a denominator that's a factor of 3. So plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1, plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 4 over 3, plus or minus 8 over 3. There's our list of potential rational zeros for this function.